Page number 60. Unit 5. Tides and ocean currents. Causes, types and effects. Unit structure 5.0. Objectives 5.1. Introduction 5.2. Tides, origin, types and its significance. 5.3. Ocean currents. Factors of origin and modification of ocean currents. 5.4. Ocean currents of the Atlantic Ocean. 5.5. Effects of the ocean currents. 5.6. Conclusion. 5.7. Questions. 5.0. Objectives: to study the origin and the different types of tides, to understand the significance of tides, understanding of origin of ocean currents, to study the factors responsible for the formation of ocean currents, to study the distribution of different types of ocean currents of Atlantic Ocean, to study the effects of ocean currents on the atmosphere and human activities. 5.1. Introduction. The sea water rises regularly twice a day at regular intervals. This periodic phenomenon of alternate rise and fall in the level of the seas is known as tides. Tides are produced as a gravitational interaction of the Earth, Moon, and the Sun. The nature and the magnitude of tides vary from place to place. Figure 5.1. Figure 5.1. High and low tides. High tide, water recedes. Low tide, water rises. High tide. 5.2. Tides, origin, types of and significance of tides. A. Origin tides. Origin of tide is due to the gravitational force exerted by the moon, the sun, and the earth. As the position of the moon in the planetary system is close to the earth than the sun, the gravitational pull exerted by the moon is therefore twice as strong as that of the sun. Whereas the sun, though bigger in size at a greater distance from the earth, hence its influence is relatively less. The magnitude of the tides, therefore, is determined by the position of the moon in relation to the earth. Figure 5.2. Figure 5.2. Height and low tide with reference to position of moon. Following the different types of tides. These tides are determined by the position of the moon, the sun, and the earth, with the reference to the rotation and revolution of the earth and the moon around itself and the sun, respectively. Spring tide. Highest tides known as spring tide occur on 2 days in a month, that is, on full moon and new moon days, that is, when the moon, the sun, and the earth are almost in a line. Figure 5.3. Neap tide. Lowest amplitude tides, called as neap tide, occur when the moon is at first on the last quarter of full moon, and the position of the sun and the moon are at right angles to the earth. During this period, the pull exerted by the sun and the moon tend to balance each other, resulting in the occurrence of lowest amplitude of tides. Figure 5.4. Neap tide. Second, aphelion or perihelion tides. The proximity of the moon in relation to the earth and the earth in relation to the sun Also, it's an effect on tidal ranges. Figure 5.5. Earth moves around the Sun in an elliptic orbit that takes a little over 365 days to complete. Its gravitational force is greatest when the Earth is at perihelion, that is the position when it is closest to the Sun on in early January, and gravitational force is least when the Earth is at aphelion position, that is the farthest from the Sun in early July. The perihelion tides occur when the Earth, Moon, and Sun are aligned at perigee and perihelion, resulting in the largest tidal range seen over the course of a year. So, tides are enhanced when the Earth is closest to the Sun around 2nd January of each year. Tides are reduced during aphelion when it is furthest from the Sun, that is around 2nd June. Figure 5.5. Figure and below the springs, low tide springs above to high spring tide. High tide normal to low tide. High tide near to low tide. The daily and semi-diurnal tides is classified on the basis of time interval between the tides. Figures 5.6. These are diurnal tides. These tides occurring at the interval of 24 hours to 52 minutes daily are called diurnal or daily tides. Semi-diurnal tides. Tides occurring at the interval of 12 hours 26 minutes are called as semi-diurnal tides. Figure 5.6. Position of Earth and Moon. See significance of tide inland. First, inland navigation or in rivers. Tides generally help in making some of the rivers navigable for the ocean-going vessels. For example, River Rhine, Elbe, Danube in Europe, River Thames in London, River Mississippi in USA, River Hooghly in Kolkata. Second, dusting the river mouths. Tides clear away the sediments brought by the river and thus maintains the depth of water near the coast that provides natural harbor for fishing and shipping. Third, tidal energy. The tidal force is also used as a source for generating electricity. For example, France and Japan have installed pump stations that convert tidal energy into electricity. Fourth, fishing activity. The large amount of fish are brought to the coast during high tides that provides easy fish catch for fishermen to earn their livelihood and a source of nutrient food, feed and fertilizer to man. His animals are cultivable land respectively. Check your progress. First one, explain the origin of tides with the help of diagram. 2. Discuss different types of tides with suitable diagrams. 3. Examine the importance of tides in human life. 11.3 Origin of ocean currents. The general movement of the mass of oceanic water in currents originate in different direction is called ocean currents. Figures 5.7 Ocean currents originate in all parts of the world and are most powerful of all features of the ocean because they drive oceanic waters for thousands of kilometers. Figure 5.7 Ocean currents. 30 degrees Celsius to 30 degrees Celsius, North equatorial ocean current 25 degrees 30 degrees Celsius. Home ocean current 25 degree 20 Celsius, 20 degrees Celsius to 30 degrees Celsius. Ocean currents. Oh, Figure 5.7.1 Classification of ocean currents. Ocean currents to temperature, velocity, direction. Temperature converts into warm, cold. Velocity and direction and dimension is converted into drifts, streams, currents. The currents in the oceans are originated due to combined effect of the several factors acting internally as well as externally, which are follows. 1. Factor related to the oceans. Local variation in physical properties of the ocean, example pressure gradient, temperature differences, salinity differences, density variations, etc. generate ocean currents. First, temperature difference. Water moves from high temperature belts to lower temperature belts. Thus, the currents from the equator move towards the pole. But subsurface water also moves from poles towards the equator to compensate the loss of water. Hence, temperature is an effective phenomenon. Second, salinity difference. As oceanic salinity difference, the density variation causes the ocean current. Salinity increases the density of ocean water. If two areas having equal temperature are characterized by varying salinity, the areas of high salinity will have greater density than the areas of low salinity. Ocean currents on the water surface are generated from the areas of less salinity to the areas of greater salinity. Such system of surface and subsurface currents caused by salinity variation is originated in open and enclosed seas. The density difference. Difference in the density of oceanic water is the main cause for the movement of oceanic water. As oceanic currents, water moves from the areas of low density to the areas of higher density. Second, two factors of related to atmospheric pressure. Ocean currents are greatly influenced and controlled by atmospheric pressure and its variation, wind direction, rainfall and evaporation, etc. These are first air pressure and winds. Water moves from high pressure areas to lower pressure areas in the form of currents due to differential water levels. Second, water level, rainfall and evaporation. Sea water levels becomes relatively higher in the areas of low evaporation and high rainfall than those areas which record low rainfall but high evaporation. Low evaporation coupled with high rainfall lowers the amount of salinity and thus reduces water density. This mechanism results in the rise of sea level. On the other hand, high evaporation and low rainfall increases salinity and water density and thus lowers the sea level. Thus, surface ocean currents are generated from the area of low water level. 5.4 Ocean currents of the Atlantic Ocean. The type and movement of the ocean currents is determined by the temperature conditions of the sea water in the ocean. Following are the types of ocean currents found in the Atlantic Ocean. 1. North Equatorial Current 1. Normally, the north equatorial current is found between the equator and 10° north latitude. The current is generated because of upwelling of cold water near the west coast of Africa. This warm current is also pushed westward by the cold Canary current. On average, the north equatorial warm current flows from east to west, while this saline current is deflected northward when it crosses the mid-Atlantic ridge near 15° north latitude. It again turns southward after crossing over the ridge. This current, after being obstructed by the land barrier of the east coast of Brazil, is bifurcated into two branches. Example: first Antilles current, second Caribbean current. Second, two South equatorial current. South Equatorial Current flows from the western coast of Africa to the eastern coast of America between the equator and 20-degree latitude. This current is more constant than the North Equatorial Current. In fact, this current is the continuation of the Venezuela current. This warm current is bifurcated into two branches due to obstruction of the land barrier. In the form of the east coast of Brazil, the northward branch, after taking northwesterly course, merges within the North Equatorial Center near Trinidad, while the second branch turns southward and continues as Brazil warm current parallel to the east coast of America. This current is basically originated under the stress of the trade winds. 3. Counter-equatorial current warm. The counter-equatorial current flows from west to east in between the westward flowing strong north and south equatorial currents. The current is less developed in the west due to stress of trade winds. In fact, the counter currents mixes with the equatorial currents in the west, but it is more developed in the east, where it is known as the Guinea stream. The counter-equatorial current carries relatively higher temperature and lower density than two equatorial currents. 4. Gulf Stream warm. The Gulf Stream is a system of several currents moving in northeasterly direction. This current system originates in the Gulf of Mexico on 20-degree north latitude and moves in the northwesterly direction along the eastern coast of North America and reaches the western coast of Europe near 70-degree north latitude. First, Florida current. This current is the northward extension of the North Equatorial Current. This current flows through the Yucatan Channel into the Gulf of Mexico. Thereafter, the current moves forward through the Florida Strait and reaches 30-degree N latitude. Second, Gulf Stream. The Florida current, after the water of Antilles current, is known as Gulf Stream beyond Cape Hatteras. This current is very wide and warm and is separated from the Sargasso Sea to its right in the east and relatively cold water near the coast to its left. Third, North Atlantic current. The Gulf Stream is divided into many branches at 45-degree north latitude and 45-degree west latitude. Longitude. All the branches are collectively called as North Atlantic Drift or Current. 5. Canary Current cold. The Canary Current, a cold current, flows along the western coast of North Africa and Madeira and Cape Verde. In fact, this current is the continuation of North Atlantic Drift, which turns the southward near the Spanish coast and flows to the south along the coast of Canary Islands. 6. Labrador Current cold. The Labrador Current, an example of cold current, originates in the Baffin Bay and Davis Strait and after flowing through the coastal waters of Newfoundland and Grand Bank merges with the Gulf Stream around the 50-degree west latitude. Brazil currents. Wow. This current is generated because of the bifurcation of the South Equatorial Current because of obstruction of the Brazilian coast near Sun Rock. The northern branch flows northward and merges with the North Equatorial Current, while the southern branch, known as the Brazil Current, flows southward along the east coast of South America up to 40 degrees south latitude. 8. Falkland Current Cold. The cold waters of Atlantic Ocean flows in the form of Falkland Cold Current and from the south to north along the eastern coast of South America up to Argentina. This current becomes the most extensive and developed near 30 degrees S latitude. 9. South Atlantic Drift Cold. This current is originated because of the reflection of the Brazil warm current eastward at 40 degrees S latitude due to deflective force of the rotation of the Earth. The South Atlantic Drift thus flows to eastwards under the influence of the westerlies. 10. Benguela Current Cold. The Benguela Current, a cold current, flows from the south to north along the western coast of South Africa. In fact, the South Atlantic drifts turn northward due to obstruction caused by the southern tips of Africa. Further northward, this current merges with the South Equatorial Current. Effects of 5.5 Effects of ocean currents. The climate of the coastal region is also influenced by ocean currents. The ocean currents therefore influence agricultural and other economic activities of coastal regions. Following are the effects of ocean currents. First, brings precipitation. Warm ocean currents provide moisture to the winds blowing from the south to the land. It helps in reducing the temperatures and so leads to the precipitation, rainfall or snowfall or drizzle, etc. For example, Gulf Stream near western coastal Europe, North Atlantic drifts along the eastern coast of Mexico and USA, Brazilian current along the eastern coast of Brazil. Second, weather and climate. Warm ocean currents of tropical move towards polar regions to provide water, while cold ocean current of polar region bring cool water to tropical water areas. This exchange warm and cool water has a moderating climatic effect on temperate coastal regions. High temperatures during summers of coastal regions in temperate areas with cold and dry climate are brought down by the presence of these warm winds. For example, North Atlantic Drift warm current, which flows along the western coast of Canada, makes the region much warmer than other places on the same latitude. Third, scanty rain or no rain. Cold current are devoid of any moisture, and so the winds blowing from the sea are dry with no moisture. These coastal regions therefore receive scanty rain or no rain. For example, Kalahari Desert and Benguela cold current of South Atlantic Ocean. Fourth, confluence of ocean currents and fishing grounds. Places where cold and warm currents meet are ideal for the growth of plankton that forms food for fish. These regions thus support a large number of fish to develop as a major fishing grounds of the world. Newfoundland on the eastern coast of North America is the meeting point of the warm Gulf Stream current and the cold Labrador current. On the other hand, these places with confluence of warm and cold current also give rise to the formation of thick fog that reduces visibility and so are dangerous for shipping. It may cause accidents of ships since the shipping traffic is heavy in this North Atlantic Ocean. Fifth, shipping and navigation. Ships sailing with the ocean current gains a natural speed, which helps to save fuel and time. Ships moving against the current lose speed. Warm currents keep the Arctic regions free from icebergs, which can be dangerous for ships. Besides, it keeps ports free from freezing during winters, thus making shipping possible throughout the year. 5.6 Conclusion. From the present study, it is very clear that tides also play an important role in influencing the weather and climate of the coastal regions. They help in the functioning of aquatic ecosystem in the coastal waters that facilitates fishing activity. Ocean currents largely govern the temperature of waters in the sea. They influence the weather conditions along the coast and play a dominant role in the temperate coastal areas. In addition, ocean currents help the shipping and navigation activities in the areas that are favorable. 5.7 questions. 1. What tides form? Draw a suitable diagram. 2. Explain different types of tides with neat diagrams. 3. What is the importance of tides in human life? 4. What are the causes and effects of ocean currents? 5. What is the significance of ocean current? 6. Define the current and describe the types of distribution of the current in Atlantic Ocean.